Hello everyone, I am Dr. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on classification of switches in the power electronics subject. So first, what do you mean by switch? Switch can make or break the circuit. So means if you see the definition, switch is a device so that is used to make the circuit or break the circuit as and when required. So if you want to make the circuit, so if you want to break the circuit, so at that situation we will use a switch device. So now what are the different types of switches? First one is a ideal switch and next one is a practical switch. First one is a ideal switch and practical switch. So first I will explain what do you mean by ideal switch. So ideal switch in this, so here when switch on condition, when switch off condition, voltage and current. So now here, so this is the diagram. This is the diagram. So now this is the time axis for voltage, current, and this is a time for this is a current voltage, and next this is a for power, so time. So now when switch is on, in ideal switch cases, when switch is on, so that voltage value is 0. It can allow the infinite amount of current. It can allow the infinite amount of current minus infinity to infinity. So now here, so suppose it is on, T on, so during turn on, and that voltage is 0. That voltage is 0. And what about this is voltage into current, that power is also 0. And now during turn off, during switch off position, so that current is 0. Switch off means that is open circuit. Switch on means that is short circuit. Short circuit voltage 0, open circuit current 0. It can withstand infinite amount of voltage. It can allow the infinite amount of current during switch on condition, and next infinite amount of voltage it can withstand during switch off condition. So now here in this case, here it can withstand some voltage. So this is a off position, and here in this case supply is this current is 0. This current is 0. Here it is 0. Power is also 0. And now here multiplication of voltage and current is also 0 in the both the cases. In this case, so this is a 1 in the next cycle, and next this is a off, on condition voltage, and this is a on condition power, and this is a T on, and this is a T off duration. And now here this is power is always 0 in case of ideal switch condition. So now here first here, what do you mean by switching time? Switching time means here switching time. Switching time means time taken to change from on state to the off state or off state to the on state. In this case, the switching time is 0. Only conduction time is present. Now here there is no switching time. Switching time is 0 in case of ideal switch. So there are two types of losses: power losses. Total complete losses are 0. So losses are here two types: conduction losses and next switching losses. So first one, so this conduction losses are 0 and switching losses also 0 in this case. So there is no switching time. So now here this loss also, conduction loss is also 0, this loss, and there is no switching loss on time taken to change the switch from on state to the off state or off state to the on state. That time is known as a 0. Because of this 0 switching time, there is no switching loss. And now here, in case of during turn on condition, that voltage is 0, so complete power loss is 0, that conduction. And in case of turn off condition, so that current is 0, and that voltage into current, that total power loss is. In any case, during on condition, off condition, ideal switch, conduction loss and switching loss is 0, and switching time is 0. And during on condition, that voltage is 0, and it can able to with this it can able to allow the infinite amount of current. During switch off condition, it can able to withstand infinite amount of voltage, that current is 0, power is 0, and here is also power is 0. This is power off. Now what about the next case? Here, practical switch. What do you mean by practical switch? Here in this case, practical switch means here, in case of practical switch, here there may be a switching time. So here, although semiconductor industry has to produce amazing devices, that is real world, so that means practical, which are not ideal. So here, limited conduction current when switch is on, and limited blocking voltage when switch is up. What do you mean by this? So limited conduction current means when switch is on. When switch is on means here this is a switch, practical switch, and now here there is a some amount of current I on. So now here in the previous case, I on is 0 during when switch is V on is 0, but here in this case there is a blocking voltage is 0, and now here this is a switch is on condition. In this case, V on is 0 and V off is open circuit, I off is 0. So now here in this case, let me draw the diagram. So now here, so first diagram, in the previous case, T and T, this is the current, this is the voltage, and this is the power. So let me change the color over here. So first one, so this is the T, time in second, ampere, voltage and power. So now here time taken to during turn on condition. During turn on condition, so in the previous diagram I will draw with this yellow color. So this is the ideal case. Ideal case. This yellow color represents the ideal case, and completely 0. So this is the current. So on condition, off condition, on condition, off condition, on condition, and off condition. So in a this is for ideal, yellow color, ideal case. And for practical case I am drawing. So to turn on, it will take some time. It will take some time to reach, and next to turn off, it will take some time. Current. So rising current and same turn on and decaying current. And same way here, turn off. So here this one, and now here this one, this one, and next here like this. So now here, so here is a, this is a power, voltage into current is known as a power. So here it is a, this is a switching time. So turn on to turn off. So T off, T on, and now here it is also same increasing, and now here it is a decrease, here it is a decreasing. So this time is known as a T off. So now here it is a turn off. So now here it can able to withstand some amount of current, and it can during turn off. So it is not completely zero, and it is not completely zero. Now here, what do you mean? Here first I will determine power loss, energy loss. So first I equals to I of t equals to, here I of t is equals to I of t equals to, this is the T on, this is T on, and this is T off, T on. So this is T on and this is T off. I of t equals to, this is T on, this is completely I by T on into T. This is the first equation, and V of t equals to V into 1 minus T by T on. So this is a voltage and current equation. Now what about the power? Power equals to V into I, that equals to V into I by T on, T minus T square by T on. So this is a power equation. So now here let me change the color over here. So first here what do you mean by energy? Energy equals to P into T. So that is integral of P dt. So that equals, what do you mean by P here? What do you mean by P here? So V integral of 0 to T on, and now here Vi by T on into T minus T square by T on. This is T on during turn on condition. So now here V by I T on. So T is T square by 2 minus T power 3 by 2 T on. Here if you substitute in this 0 to T on gets cancelled. So now here V by Vi by 6. So that is a T on. This is the energy equals to energy during on condition Vi by 6 into V T on. So now same situation for the T off. So now here V of t equals to and I of t equals to V of t equals to and I of t equals to, that I will write V of t equals to here during rising. So V by T off into T. So that is V by T off into T, and now here this is decaying. So now here I into 1 minus T by T off. So that is here. So V by T off into T, and now here I into 1 minus T by T off. So now power equals to V into I, that equals to V into I by T half into T minus T square by T off. So now here P equals to power into T, that equals to integral of P dt. So now here E is equals to integral of 0 to T of V into I by T of T minus T square by T half. So now here if you simplify this, this is also V by 6 into T off. So this is a E off equals to V by I into 6 T off. So this is the equation. So now here, what do you mean by? So complete energy loss equals to, in the switch equals to energy loss during turn on and energy loss during turn off. So that equals to V into I by 6 T on plus V by I 6 T into T off. That equals to V by I by 6 VI by 6 T on plus T off. So that is complete energy. So this one. So now here power equals to E equals to P into T, and now that equals to P into P by F. T means time period, the reciprocal of this one. So now here this equals to, so power equals to E into F. E value is here, so substitute in this. So this is regarding energy loss during turn on and turn off. What about the this is the switching, this is completely switching loss. What about the conduction loss? Conduction loss means V into I integral of 0 to T on dt. So this is a conduction loss. So this one. So now this is regarding switching loss. So now again the switches are classified into on the basis of controlling. So there are three types of controlling: control switch, uncontrolled switch, semi-controlled switch, and fully controlled switch. What do you mean by uncontrolled switch? So here in case of uncontrolled switch, so that controlling is based on the supply only. So turn on and turn off is not in our hand. So here if you take an example, that is a diode. Diode is the best example. So in case of diode, so here turn on and turn off based on the supply only. In the diode case, this is a diode symbol. So here if you give the positive supply, negative supply, based on if it is the circuit supply, if you give positive supply to the P terminal and negative supply to the N terminal, that is forward bias, it will conduct. Now here if you take reverse terminals, so it will not conduct. So turn on and turn off not in our hand, in the hand. So based on the supply only. So it is an uncontrolled device. So the best example is a diode. What about the semi-control? So here either turn on or turn off is in our hand. So if turn on is in our hand, turn off is not in our hand. If turn off is in our hand, turn on is not on our hand. So the best example is a SCR. SCR means thyristor. Turn on we can give. So V anode current is greater than 0. And next, if you give gate current, then it will turn on. So if you give the gate current 0 and if you give negative gate current, so it will always conduct. So it will continue to conduct. So when it will turn off, when you give external device to turn off, so then only it will. The best which device is used to turn off SCR? So commutation circuits, class A, class B, class C. So turn off is not in our hand, only turn on is in our hand. So this is a semi-controlled switch. The best example is a SCR. So what do you mean by fully controlled switch? Fully controlled switch is a GTO. GTO means gate turn off device. So VA is greater than 0 and IG is greater than 0. So it will turn on, and VA is greater than 0 and IG is less than 0. In this case, we can turn off. Turn on and turn off is in on our hand. So GTO is the best example for fully controlled device. And IGBT, MOSFET, power MOSFET, and power BJT and next track. All these comes under the fully controlled devices. So now here, based on the blocking. So which can block both the polarities, which can block only one polarity. So the best example for unipolar switch is same diode. So which can block only one polarity. One polarity means here, so it will allow the current only in one direction. So that is from anode to the cathode. So it will block, it will allow the only positive current, it will not allow this. And next, which it can block reverse voltage. So the best example is a diode. So now here, what about the bipolar switch? So which can block both the polarities, which can block both the polarities means here this one, it will allow the only one. So now the best example is a SCR is a bipolar switch, which can block the both the polarities is known as a bipolar. Here switch is different, bipolar switch is different, bipolar device is different. So now here bipolar switch means here SCR on the basis of control flow. On the basis of control flow means unidirectional and bidirectional. What do you mean by unidirectional? So diode allows only from anode to the cathode only. That is unidirectional device. And now here SCR is also current is flowing from anode to the cathode, not cathode to the anode. So diode and SCR comes under the unidirectional devices. What about the bidirectional device? Triac. GTO is also unidirectional device. It is a, even though it is a fully controlled device, but the current direction is for the GTO is current direction is always that current direction is always anode to the cathode. That is triac is the best example bidirectional in the triac. So both the in the triac both in both the directions from MT1 to MT2 and MT2 to MT1. So now here current can flow. So bidirectional switch is the best example is the bidirectional switch is the best example for the triac. And now here, what do you mean by diode? So diode is a uncontrolled switch. Uncontrolled switch means turn on and turn off is not on our hand. So the diode symbol is like this. So it will turn on and turn off depends on the supply. So diode is in forward bias condition, it will turn on. Diode is reverse bias condition, it will turn off. It is also unidirectional. Current can flow from anode to the cathode. It can block the reverse polarity. So now here the save of operating area is a second quadrant. And now if you draw the VI characteristics means this one. So it can block the reverse polarity and it can allow the only from positive current, that is anode to the cathode. What about the SCR? So it is a semi-control. Turn on is in our hand, but turn off is not our hand. So here we need the external device to turn off. It is a semi-controlled switch. So here this is a SCR symbol and anode, cathode and gate. Here anode voltage is greater than 0 and IG is not equals 0. IG is greater than 0, it will turn off. And now here unidirectional current. From anode to the cathode only current flows. So it is a unidirectional. From the cathode to the anode it will not flow. Both the direction current is not possible. So it is a unidirectional switch. So which can block the both the polarities. So now it can allow the only one direction current. So here which can block the polarity. So safe operating area is the first and second, SOA. And next, what about the GTO? GTO, gate turn off device. It is a fully controlled switch. So fully controlled switch means this is a GTO, this one GTO, this one anode, cathode and gate. Next here fully turn on. How we will turn on? VA is greater than 0 and IG is greater than 0. VA is greater than 0 and IG is less than 0. If you give the positive current and it will turn on, and if you give the negative current it will turn off. So turn on and turn off is in our hand, but turn off is also not in our hand. It is a fully controlled device, but current is always flows from anode to the cathode. It is a unidirectional switch, so which can block both the polarities, positive and negative, and it will allow the flow of current. So safe operating area is the first and second. So now here triac. What do you mean by triode? For alternating current device. So now here it is a fully controlled device. Turn on and turn off is in our hand, and it is a bidirectional switch. Current can flow from in both direction, MT1 to the MT2 and MT2 to the MT1. Here it is a triac symbol. So now here MT1 and MT2, and there is a gate MT1 to the MT2, and it is a bidirectional switch, turn on and turn off. So here it is a bipolar switch which can block both the polarities, and it can allow the, so here safe operating is here 1, 2, 3, 4. And now here triac, transistors. So transistors turn on and turn off is in our hand. So current is unidirectional, and that it is a unipolar switch which can block only. So safe operating area is the first quadrant. So but here transistor, MOSFET, IGBT is also bidirectional switch, fully controlled switch, bidirectional switch, and unipolar switch. Bidirectional means unipolar, only positive it will current and voltage. And now here the table switching devices ratings I have given. So here thyristor, this is the SCR, triac, GTO, power BJT, and next power MOSFET, and IGBT. So turn on duration as compared to short duration gate pulse. So as it is for thyristor, for triac, as it is thyristor for GTO. And next here, these are the ratings are important. So 1200 volts by 1500 ampere, and forward voltage drop is a 1.5. So these ratings, and it is also 1200 volts by 300 amperes, 1.7 volts, 1200 volts by 600 amperes, that is 2.2 volts, and next 400 volts by 250 amperes for the power BJT, and current voltage, forward voltage drop is a 1.1, and 900 volts by 200, 1.5. So that is a for power BJT, and this is for power MOSFET, and next IGBT. These are the switching times in microseconds. So now here I hope all these are reference books here. The best book here, the P.S. Bimra and M.H. Rashid book, Umanand and Mohan and Ullai. So now here I hope all these concepts are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.